Let's talk about sine and cosine graphs with a focus on the period of the graph. So the period of a function is how long it takes, usually in x units, so horizontal direction, it takes for the function values to repeat themselves. So here I drew kind of a poor sketch of a sine function. I have rulers and grid paper right here, but sometimes, whatever. Like I even used the wrong dot here. But it's fine, it's just a sketch. So the period is how long it takes to go from essentially one point on the graph to the same point, but include the entire behavior of the function. So from this point, we go up, back to the midline, down, back to the midline. That is one full period. It goes back to the midline, but that's just an uppy loop. The downy part here, that is the technical term, please use it. One period of a sine and cosine graph needs to have one full uppy and downy portion. But the uppy and downy portion can be wherever. You don't have to start at 0 and go back to 0. You go from the max to the max. So most of our trig functions, and when I say most, I mean 4 out of 6, have a period of 2 pi. Tangent and cotangent have a period of pi. Now with sine and cosine graphs, the period constant is this Greek letter, looks like a W, but it's a lowercase omega. Now don't mix that up with the period, which is called t. So the general ways you can phrase the functions are f of x equals sine of omega x, or cosine equals omega x. But if you want to, instead of using omega, you can use t right in the formula, which is sometimes easier because the period is what you see on the graph. If this was 0 to 10, the period would be 10. You'd put 10 in for t. And the thing about that is that we use 2 pi because there's 2 pi radians in one complete revolution. Remember from class, this is based on the unit circle. So going all the way around the unit circle once is 2 pi radians. If you were using degrees, this would be 360 over t, just to change the units. So the key formulas here are omega equals 2 pi over t, t times omega equals 2 pi if you multiply both those, or t equals 2 pi over omega. In some problems, you'll be given omega in the formula and asked to find the period. In other ones, you'll be given like a graph and you have to get the period from the graph and then find the value of omega. During this entire video, you probably noticed I've been running Desmos here with this graph animating. And that is exactly what we're doing here. If you put in the formulation like this, 2 pi over t, and then you set t to something like 8, the period is going to be 8 units. 1 up, 1 down, you come back here at 8. This is -6 is the x, this is 2 is the x, so still 8 units in this direction. If you phrase it like this, with sine of omega x, it's a little tougher to see the relationship between the graph and the value of omega. If I set omega to 2.4 or even a round number like 3, it's kind of difficult to see how that shows up on the graph. Although Desmos is nice enough to label this as pi over 3. So here you'd get that the period is 2 pi over 3, which go back to the formula here. If I say omega equals 3, then that means that the period is 2 pi over omega. So again, I got a period of 2 pi over 3 on the graph here. So let's do an example. Just look at this same thing from before. We're going to find the period t and the period constant of the above function. So we can go max to max or min to min or whatever. Usually it's the easiest just to go from a point on the midline up a loop, down a loop, back to the midline. And you can see that happens here in 10 units. X equals 0 to x equals 10. So we know that t equals 10, and we know that omega equals 2 pi over 10. And of course we want to reduce that, so we'll say omega equals pi over 5. If there's no horizontal shift, then we'd have f of x equals a, the amplitude we found was 6, times sine of pi over 5x. Midline was 3, so we write plus 3. And then we could graph this in Desmos and see that it generates the same thing as here. So the only remaining question you might ask is, how did I know this was a sine function? Because a sine function, if it's not horizontally shifted, starts at the midline going up. A cosine function would start at the maximum going down. So that's just what you want to do to make your life easier, is just figure out, is it easier to make this a sine function or a cosine function based on that y-intercept behavior?